Today, our topic is intermediate statistics, which is regression analysis. And we have our expert, Dr. Hamiza Bintesat. She actually done her master's in medical genetics from the University of Glasgow University and has done her PhD on patient decision aid modeling from the UM. Although she is expert in genetic counseling and mixed method research and behavioral science, she is also expert in regression analysis also. So I hope all of you will get a good source of information from her. And I think most of you need to do for your thesis some kind of regression analysis, and that's why it's very important topic for you all. Sorry, I forgot to introduce myself. So I'm Tanya, will be moderator for this session. Maybe we can start. Dr. Hamiza, the floor is yours.
Thanks, Dr. Tanya, for the introduction. You can hear me, right? Okay, all right. Sure, shall we start? You can see my screen. All right, so thank you everyone for taking your time for the seminar today, research seminar today. So the topic for today is regression analysis. I'm Dr. Hamiza from Department of Surgery. So before we start, I have a disclaimer to make. I'm not yet an expert for the regression analysis. It's actually a quite big topic to cover in 1 hour, but this is more to sharing sessions that I've done some registered regression for my research. So for the learning objective for today, I will cover what is the regression analysis and its purpose, and to understand its practical implications, and also to introduce some commonly used regression in health research, and also some example on interpretation of the regression analysis in healthcare research. So what is regression analysis? Regression analysis is a set of statistical methods used for the estimate of relationship. So it estimates the relationship between the dependent variables and independent variables. So it measures the strength of relationship, but it doesn't mean the causative factors. It doesn't mean that, for example, if blood pressure is increased, then for example, if someone have sleep duration is long, it does mean that it of course will cause high blood pressure. It's not causative effect, but the strength of relationship for independent variables. In other contexts, for example, in business, it can be used to predict future relationship. For example, what is the estimate growth of business if they do some certain of advertisement, for example. So this is usually being engaged by the non-experimental research design, in which the variables are not deliberately manipulated or controlled. There are many examples of regression analysis, and it also can be very complex. But for today, I will just cover the 3 most commonly used regression analysis, which is simple regression, multiple regression, and logistic regressions. And regression analysis can be linear and also non-linear. It also can have a sigmoid shape. And to choose what type of variation of regression analysis that is suitable for your research, it depends on your research question and type of data you have. So this is a simple linear regression. This can be expressed by this equation, YA plus BX plus epsilon. So your dependent variable will be Y on the Y-axis, X on the X-axis, your intercept and slope, and also the residual error, which is something that we cannot explain through the models. So through this linear regression, we try to find the best fit for the relationship between your variables. So the example that I use here is, so for example, a researcher want to investigate the relationship between sleep duration in hours, which is your independent variables, and blood pressure measured in millimeter mercury for a group of adults. So your equation will be blood pressure, which is your dependent variables. And beta 0 is your intercept, which is what is your predicted blood pressure when sleep duration is 0. Although in this case, it's actually not meaningful in practice. Your beta 1 is your slope, which is what is the predicted blood pressure for every 1 hour increase in sleep durations. And epsilon is the error, which is the random variation that cannot be explained by the model because no model is actually perfect. So like any other statistical model, there is an assumptions underlying for that model. For in this case, this is 6 in fundamental assumptions. First is dependent and independent variables show a linear relationship between the slope and the intercept. Independent variable is not random, and the value of the residual error is 0, constant across all observation, not correlated across all observation, and it follow normal distribution. So multiple linear regression also commonly used in research in health, but the difference now it has multiple independent variable. If you can see the graph is more than one line, it's more than one independent variables. And then it has same condition as the simple linear models, except that it must have the mandatory condition, which is non-collinearity, which is independent variable should show a minimum correlation with each other. It must be not strongly correlated with each other for the independent variables. For example, for now, the example that I used just now, we add on 2 other independent variables, which is age in years and also body mass index. The beta 0 is still the intercept. Beta 1 is now is the sleep durations. And beta 2 is the age, and beta 3 is BMI. So the multicollinearity can be identified. If you use USPSS, it can be identified by you observing the correlation matrix. If it's close to 1 or 0 or -1, it might indicate multicollinearity. And also the value of variance infection factor. If it is more than 5, it maybe have multicollinearity problem. It means that your independent variables is highly correlated with each other. So to address these multicollinearity problems, you must consider to drop one of the variables or combine variables. For example, if your independent variable, for example, one is parity, and then the other one is number of children. If this can be quite close, the concept can be quite close to each other, you might consider to drop one of the variables. So that if your multicollinearity is low, so your model is more trusted to predict your relationship between variables. So for example, in this case, blood pressure, your independent variables and for age and BMI might have might have issue of multicollinearity because we know that people with older age have usually have high BMI. So how we interpret the multiple linear regression? So the things that we should stage, we should observe in interpreting the multiple linear regression, we have 5 points. First is overall model fits. You should see the R square and adjusted R squared. For in XPSS, it provided if the value is close to 0, close to 1. So it means that your model is actually good to predict your relationship for your research. And then you also need to see the value for the F-test and also the p-value, whether it's statistically significant. And then you also need to observe the individual variable significance. So there is, for example, the independent variable that you use just now is the sleep duration, age, and BMI. You observe each one of the independent variable, what is the coefficient p-values, and also the sign, whether it's positive or negative. The sign also determine whether it prove your hypothesis or not. And also measure the multicollinearity. This can be measured using SPSS. You can just click the box. But however, you need also to be aware that even if there is no multicollinearity issue observed by the SPSS, you as a human being, as a researcher, need to think whether your variables are actually related or strongly correlated with each other. For example, the age and BMI that I just mentioned just now. And also the residual analysis. This is not shown in the table, but it can be visually inspected using residual plots to ensure your data is actually normally distributed. So it's actually it didn't violate your assumptions. So back to the example that we used just now. So if the number of R squared value is close to 0, then your model is actually good to predict your relationship, to be used to predict your relationship between dependent and independent variables. And then looking at the individual coefficients, if it have low p-value, which is statistically significance, look if it is negative or positive. It's negative, it support your hypothesis, means that longer sleep is actually associated with lower blood pressure. If positive, and it's positive, then it suggests blood pressure actually increase with age independent of sleep and BMI. It's actually whether you already consider the other independent variables, your relationship is still significant for each independent variables that is predict predict the dependent variables. All right, so this is some comparison to show between these three. So what type of regression you use should depends on your data, whether it's continuous, whether how many of independent variable you have, and then what kind of output you want to present, and then what kind of assumption you should have for your type of analysis, and then how it can be applied. For the logistic regression, the dependent variable is usually binary 0 or 1. For example, someone you want to predict whether someone who are BRCA carrier are likely to remove their ovary based on independent variables such as their children, they are married. It can be one or more lah. So usually in the research we have even more than 3 independent variables, and then the prediction is the probability of an event. For example, the independent significant variables is significant between having children, parity, married, then it can predict predict that someone might choose to remove ovaries. This is probability of an event lah. Usually indicates as a value 0 of 0 or 1. So 1 is someone choose to remove, 0 means not to remove. It also have similar assumptions. It should be no collinearity between independent variables. And then it's just that the outcome is different type of data. So this one, I will skip this one. So apart from SPSS, there's other things. You can actually do your regression analysis using Excel and other type of software. For Excel, actually you need to install the add-in for your Excel. There's some differences. I mean, that's all just an overview for the regression analysis. I didn't show any practical because I think it's too complex to be shown in just 1 hour. Anyone have question? If so, anyone, if there is a question raised, I think the then also can help me and answer some
Yeah,
questions.
yeah. I think, can I ask you all, like, how many of you are doing regression analysis? I can see 11 participants already, right? Maybe I need to call the names. Uh, Hazik, are you doing the, hi,
Hi, afternoon. Yeah.
Yeah. So are you doing any regression analysis for your study or?
Yeah, I don't think my study model uses this regression analysis.
Okay. So anyone in here doing regression analysis? Any type of?
No one.
Really?
I don't know. But
Uh,
Hi,
mm-hmm.
Prof.
honest.
I think I'm doing multiple regression analysis on my study lah.
Okay.
How
Yeah.
far it
Sorry,
how far it has goes your analysis complete already?
not yet. I just started only. Haven't even started collecting data, but the analysis is most probably using that lah.
Okay. If are you very new to statistics?
Unfortunately, yes.
So the references that I show actually show you step by steps how to do it and which button to click. I think it can be if it can helpful for you.
Yeah. Okay. Thanks.
May I know what is your research question or what exactly you are looking at?
I'm trying to do a prediction model for sentinel lymph node metastasis in early breast cancer. So my variables will be multiple variables such as age, breast cancer tumor size, and the pathological biology of it, such as ER/PR positive. Then the outcome will be how many percent is the probability of a sentinel lymph node is positive lah after harvesting it.
Okay, so like your main outcome is sentinel lymph node positive or negative, right?
Yes, correct.
So maybe then it might be logistic regression. Logistic. I found like most of you do logistic regression. Like okay, when the outcome variable is yes, no, or having cancer or not, something yes, no means binary. On that case, actually, we do logistic regression. And if you see the logistic regression criteria to check before analysis, like Dr. Hamiza showed you all that what are the assumption you need to fulfill before. One good thing is for logistic regression, actually, you don't need to have uh, your data to be normally distributed. This is a good point for logistic regression because normally before you start doing any of your statistical analysis, you need to, once you collect your data, you need to check whether your data is normally distributed or not. And then depending on that, you can find that most of the assumption, to meet the assumption, first assumption is your data normally distributed or non-normally distribution. Then different type of analysis you need to do. For logistic, you don't have to, your data don't need to be normally distributed.
Okay, understand.
Uh, and just now you mentioned like, I think Dr. Hamiza already mentioned like what are the covariate or independent variable you can adjust in your model and can see those things in your regression model. Uh, is is there any question from anyone? Dr. Hamiza, maybe can you share something like any statistical site or website they can follow to see the analysis or maybe to check their assumption, something like that?
For website, actually there is many.
Yes.
There is statistic solutions.
Mm.
There is stats from advanced research computing. It even show what kind of output will be generated from the SPSS. But for the books that I mentioned just now, it is SPSS Survival Manual, a step-by-step guide to data analysis. So it's actually guide you step by step what should be done first.
Maybe because we have enough time, maybe you can just share. And there is another one you can actually follow for the assumption and to see the analysis step by step also. That one is LARD, LEARD, LARD something.com, I think. Uh, One example, can you show Dr. Hamiza? Maybe you just now you mentioned another one also.
So this one, what I showed just now, what should be interpreted. This is for regression analysis. R square, adjust R square, so you see if it is close to 1 or not. And then the coefficient for each independent variables, with this is statistically significant or not. And also what is the value, positive or negative. The coefficients, this one, whether is significant or not, whether it's closely related or not. Yeah, I think this is the all main point that should be observed in the regressions. So the website is start OARC from University of CLA.
Is it clear for you all? Like once you Google, actually some of the site shows you like what are the criteria to fulfill your model. Because whenever you do your study in the regression model, any type of regression, like you need dependent variable, which is your outcome variable, then independent variable, and what you need to check the assumption. Just now, Dr. Hamiza showed that's how you can actually see. So you got some idea, basic idea. Sometimes you go to statistician or take help from the others researcher, but at least if you see those sites and check, okay, the regression model or logistic one or anything, then you can check the criteria. So you have the idea like what you need to see. Even if someone do for you, still you have the idea like what you are doing. Because often we found that in the evaluation time, students stuck more on these statistics things. They finish everything, but cannot answer at the end why did logistic regression or why choose this model, something like that, or why you did regression, linear regression, or anything else.
But I think it's very important to ensure you use the right analysis so that it won't waste your time to need to go through all the process again.
Yes, I agree. Uh, Anyone has any question or anyone doing any kind of research maybe related to the regression model?
Anyone want to share their research and what type of regression analysis they use other than Jonathan just now? Okay, Tanya.
Seems like, are you all from year one or second year? Which one? Yeah, for clinical masters?
Just entered second year.
Okay. That's why you just started your research, right?
Yeah, I just
Mm,
calculated the sample size from the likely model that I'm using lah, basically. Yeah.
okay. So maybe at this point, you just decide what analysis you will do or what research your model, and then what regression or survival or what type of statistical analysis you need to do. And then the most important thing, I think, for at this point, before you start your regression model, identify your outcome variable and also which is your dependent variable, what you are looking for, and your independent variable. And from the literature review, please go through the independent variable you need to see in your model. Okay, just now Dr. Hamiza said, like, okay, and age need to check. If any kind of cancer, obviously age has some impact, maybe stage of cancer at of that patient, sometimes ethnicity, sometimes gender also matter. So different things, you sometimes in the regression model you need to adjust. And that's why before you start your study modeling, then you need to go through the literature and see what are the factors that can have impact on your model, and need to adjust or exclude depending on the data. Okay, this is very important thing, I think. I think if no one has any question or anything to share, maybe we can finish the session. Anyone has any other question or information you want to know? Okay, I think that's all for today. Thank you, Dr. Hamiza, for your nice presentation. And anyone has any thing want to ask, or can email us or can contact us. Okay, we are inside in department. You can find us also. Okay, thank you.